Everybody, Mr. Fugay here. Hope you're having a great day today. If you're here, it sounds like it's time for us to talk about transversal angle relationships. So that's what this lesson is going to be about. So I'm going to start you off with a short warm-up, and I would like you to take a moment to pause this video right away and try to answer these questions. For each angle pair that I give you here, I would like you to determine whether they are a linear pair or a vertical angle. Pause now. All right, welcome back. Let's go ahead and let's answer these. So G and F are going to be on the same line and they are across from each other or non-adjacent. So by definition, this would be a vertical angle. In the terms of E and F, however, E and F are going to be also, well, on the same intersection. But in this case now, they are next to each other. They are adjacent and their non-common side, which would be the ones that I'm hovering over here, create opposite rays, aka a line. This would be a linear pair. So there's one example of each so far. And for the remaining ones, A and C, we go up to this next intersection. Once again, they're adjacent with each other, so that's going to be a linear pair. And then B and C end up being across from each other, so that would make them vertical. Now, if you notice, the first two that I went over involved the bottom intersection of G, E, H, F. The top one involved A, B, C, D. The problem with this last question is angle A is part of the upper intersection here, and angle F is part of the lower intersection. And so we don't have a name for that one yet, actually. So if you weren't able to answer that one, that was the correct answer. The answer was there is no answer until you watch this video. And that's what we're going to be discussing right now. So we're going to talk about situations here where we have angles that are located at different intersections but are connected to each other by a line like it is here. And that particular line is our first vocabulary term, which is transversal. So let me throw up a few definitions on here so that you can pause and jot them down, and then we'll discuss them. Just made them magically appear. Here are those definitions. Go ahead and I'll pause for a minute to let you jot these down. But once I have them written down, let's talk about them a little bit. So the first one is transversal, which is a line which passes or crosses two other lines. So it connects the two lines together, which then, of course, connects the intersections together. So in this situation here, we're looking at line L, which is a connecting line of lines J and K. So we would call line L our transversal here. In the drawing, and it's also to my right here. Now we're going to talk about some special names for angle pairs that are created when a transversal connects these two intersections. So the first one we're going to talk about, and I'm going to use some color for this, is a corresponding angle. So corresponding angles are going to be two angles which occupy the same position at each intersection. Now, what do I mean by same position? Well, if I go over to my diagram here, let's talk about angle A for a minute, okay? Angle A is located above line J and to the right of the transversal line L. Remember, line L is the connecting line. So down at the intersection down here at the bottom, which angle is going to be above its line, in this case K, and also to the left of the transversal? Well, that would be angle G. So one example here of a corresponding angle would be angle A and angle G. Now, what are some other ones here that we could use? Angle B would be corresponding with angle E because they're both to the right of the transversal and above their lines. Remember, lines are just going to be the other lines that make the intersection. C and H are corresponding, and lastly, D and F are going to be corresponding. The next definition is alternate interior angles. I'll use green for this one. So alternate interior angles are going to be a pair of angles that are both going to be inside of the two lines, so in between the non-transversal lines, but opposite sides of the transversal. So as an example, angle C right here is located on the interior of J and K. And we'll talk about interior and exterior in just a split second. So the alternate interior means that I'm going to pick the other interior angle at the intersection here that is on the other side of the transversal, so in this case, E. Now, before I go forward, I should give you two additional side definitions we need to note. So there are what we call interior and exterior angles when we're discussing lines and transversals that are connecting. So in this yellow space that I'm now highlighting, all of the angles located inside here would be considered interior angles. So these are considered interior angles. And then the angles that are outside of the lines, so that in this case would be A and B up in the top section, and then down here would be H and F in the bottom, these would be considered our exterior angles. So let's write that down. And these change depending on which intersections we're comparing with one another. So in the case of J and K, the interior of J and K is angle C, D, E, and G, and the exteriors are A, B, H, and F. Here are those definitions, so you can jot them down. Pause the video if you need to write that down. So angles between the non-transversal lines is interior, angles outside the non-transversal lines. So that's why for alternate interior angles, C and E would be a pair of them. The other pair would be D and G. D and G. They kind of make like a little like zigzag, like a Z. That's kind of one way I help myself remember when we're working with that. So on the contrary, we now talked about alternate interior angles. What about alternate exterior angles? So alternate exterior angles, we'll use a blue for this, are going to be angles that are both outside of the two lines but on opposite sides of the transversal. So in this example, angle A, which we'll use a second time here, angle A's alternate exterior angle would be angle F, because they're both exterior and they're both located on the opposite side of the transversal. So going back here, if you want to have one example. So we said angle C and angle E for alternate interior. Alternate exterior would be angle A and angle F. Okay? We have two more definitions, and then we'll look at some guided practice here to wrap up this video. So corresponding angles, alternate interior angles, and alternate exterior angles so far. The last two are what we call same side interior and same side exterior. Some textbooks and some worksheets and some assignments you'll see will call them consecutive interior and consecutive exterior, but I like to call them same side. So notice in this one, this is a pair of angles that are inside of the lines, but are on the same side of the transversal. So in this example, if we're picking two angles, and let's erase some of these markings here, we'll get rid of these. Oh, well, I don't want to get rid of the highlight. We're never going to get rid of it. We'll be fine. So angle G, which I'll put a circle around, the other interior angle that is on the same side of the transversal would be angle C. So angle G and angle C are an example of same side interior angles. And then when we talk about same side exterior angles, we'd be talking about angle H, because it's on the exterior, and also angle A, because it's on the same side of our transversal. So this would be angle A, and then angle H. So that's all the definitions we have, and so there are a total of 5 different types of specific angle pairs that are going to happen or occur when we have a transversal connecting two intersections to one another. So let's take a look at some examples of this, and that we can look at a different diagram where we can do the same thing here. So in this figure at the right, I would like you to identify 2 pairs, at least 2 pairs, of each type of angle. So take a moment and pause this video so that you can try that yourself. And then when you're done, we'll go through some different examples to make sure you're correct. Okay. So let's start with corresponding, and in between I'm gonna use blue to highlight them, but then I'll eventually erase them between each question. So corresponding angles, remember, means same position. So the first thing I need to identify is our transversal, or our connecting line, is going to be right here. So we should probably use that. Highlight that. That'll help us out when we're answering some of these. So corresponding angle, if we take angle 1, the corresponding angle that is above the transversal and to the left of the respected line would be angle 5. So angle 1 and angle 5 is one of the examples, but then there's a bunch of others. 2 and 6 would count, 3 and 4 would count, and then the last one would be angle 4 and angle 8. You only need to list 2, but we technically had 4 possibilities for corresponding angles. So you can see in those cases they're located in the same position at each intersection. Then we move to alternate interior angles. So now we're only looking at our interior angles, which are going to be these guys right here. Those are in between the lines. So we need 2 angles that are on opposite sides of the transversal, and of course at different intersections. So angle 2 and angle 7. Now the reason you might say, well, why can't I say angle 2 and angle 4? Aren't they technically on opposite sides of the transversal? That's true, but 2 and 4 already have another relationship. 2 and 4 are actually going to be linear pairs, and we'll get to that in just a moment. The only other pair that we could go with here is angle 4 and angle 5. Using the same idea for alternate exterior angles, but instead now we're going to look at the ones outside here. Alternate exterior would be angle 1 and then angle 8. Once again, we can't say angle 1 and angle 3 because they're technically linear pairs. So we're picking them at different intersections. And the other one would be angle 3 and angle 6. Then we go to same side interior and same side exterior. So remember, now we're back to the blue for same side interior. I'm going to pick 2, and then one on the same side of the transversal would be angle 5. So it's angle 2, angle 5, and then the last one would be angle 4 and angle 7. So those are my 2 same side interior angles. And the last new definition, same side exterior, would be using the ones in green there again. So angle 1 and angle 6 are both above the transversal, and angle 3 and angle 8 are both below the transversal. So these are examples of same side exterior angles. So the objective in this video is just to be able to identify these special angle pair types in these situations. Now there's more we're going to do with that, but that's going to come in future lessons. Now, backtracking to what we learned in the previous lesson, we can still talk about vertical angles and we can still talk about linear pairs. What I need you to think about when we look at these 2 definitions is these always have to occur on the same intersection. So all the ones we've learned in this video today, these are occurring at different intersections, but the 2 that we learned in our prior lesson, these would occur at the same intersection. So now for vertical angles, if let's erase everything here, we'll start clean. So I'm just going to look at this intersection right here and see, oh well, angle 1 and angle 4 would be considered vertical, and then angle 2 and angle 3. Then if I go to the other intersection, again, we're looking across from each other, angle 5, angle 8, and then last but not least, angle 6 and angle 7. Using this same concept, we also can apply this for linear pairs, except now there's a bunch of these, so we're not going to write all of them. I'm just going to take 2 from each intersection. So angle 2 and angle 4 would be one example. And then we could say maybe angle 3 and angle 4. So we're taking ones that are adjacent to each other at the same intersection, and they also create a straight line. Now there's others, but I'm not going to write them. And at the other intersection, we'll do, let's say, 5 and 7. So angle 5 and angle 7. And then the last one we'll pick here is, we'll go with 6 and 8. Why not? Okay. So that's what I want you to take away from these ones here, is the ones that I'm highlighting in blue, corresponding alternate interior, alternate exterior, same side interior, and same side exterior. They always occur at different intersections versus the vertical angle and the linear pairs, which occur on the same intersection. So before we wrap up this video, because I am running out of time, here are 3 final examples. This time I've given a more basic drawing, and I just want you to tell me which one is which. So pause the video, and then I will go through these, and that will wrap up our lesson. So I'd like to always draw the transversals. So let's connect the intersections with that connecting line, my transversal. That will help us out a lot. 5 and 4 are both located on the inside of the lines, and they are on opposite sides, so we would call this alternate interior. Alternate interior in that situation. Whereas in numbers 2 and 7 are both located outside of the lines, right? They're located outside, and they are also on opposite sides of the transversal. So this time these would be called alternate exterior. And then for our last one, if you're looking at interior versus exterior, 1 is technically an exterior, 5 is technically an interior. So those alternate interior or same side exterior definitions, none of those work. But what we do know is that 1 is located above the transversal and to the left of the line. 5 is above the transversal and also to the left of the line. So these then would be considered corresponding angles. So corresponding angles technically have always one interior and one exterior angle. So that might be one way to tell corresponding angles apart from the other 4 definitions. So that'll conclude this video. I hope you found the information helpful here, but certainly if you have any questions, you can certainly talk to me in class. Thank you guys for watching, and I hope you have a good rest of your day.